Hi Year 10, we're on to the final lesson for the day. I hope you're having a similarly exciting Saturday. Now, here we go. So, volume of right prisms and cylinders. So this is stuff you've done before, maybe presented slightly differently, but this isn't new content today. We're reviewing how to find the volume of certain three-dimensional objects. That's the amount of space in them. And to start with, yes, there's a general rule you can use for the volume of all right and oblique prisms and cylinders, and that's volume is the area times the base. I think the better term here to remember is that idea of uniform cross-section. All of these objects here that I've shown, the square-based prism, the cylinder, and my highly technical blob, do not use that term. That is just me trying to demonstrate the principle of volume is area times height. The idea is these objects all have a uniform cross-section. If you cut them anywhere along there, they're going to show the same shape. In this case, anywhere I cut that object, it should show a square. Anywhere I cut this object, it should show a circle. Anywhere I cut this, it should show that same blob shape that exists through the whole object. All right? So wherever you've got this case where you've got a uniform cross-section, the volume is simply the area times the perpendicular height, which is a bit of a trick. So I'm going to write that up where A is the area of the base and H is the perpendicular height. And that's particularly relevant for this first one here that you can see is on a bit of a slant. We need the perpendicular height, so the one that's at right angles to the base. As long as we have that perpendicular height, we can work out the volume no problem. I'm going to use this principle here to actually derive some formulas. In this case, for example, volume is AH, but what's the area of the base? The base is a square. What's the formula for the area of a square? You should be able to tell me that's S squared. So in turn, I can write the volume of a square-based prism like that as being S squared times H, whatever the height is. Fair enough? If it was a rectangular prism, so if it was a rectangle at the bottom, you'd still have your volume is A area times the height, but in that case the area of the base would be length times width. So if we put length width back in here as the area, we get that more common volume formula that we have for rectangular prisms, which is length width height, which I'm sure you've used for many years in many happy situations. Cylinder here, what's the area of the base of the cylinder? It's a circle, isn't it? So we can start off with volume is area times height, but the area of a base is the same as the area normally of a circle. The area of a circle is pi r squared. So in turn, if I put pi r squared in as h, volume is pi r squared times height. And that's the formula that you've probably always seen and used for the formula for the volume of a cylinder. So, you know, when you go and work this out now, you could always work out the area and then use that formula, or you could just directly use the formula pi r squared height. There are multiple ways of doing it, and they're all mathematically sound. It's perfectly fine. Blob here, well, blob, there's not going to be a way of easily working out what the area of that surface is. So that's a situation where you would just be using volume is AH and hope somehow you know the area of that surface. So for example, let's actually do some examples of a couple of these. I'm going to rub off some of it here. I hope you're going to remember your rectangular prism formula, because that will come up somewhere. And there we go. So let's say that blob here they told us that the area there is 62 centimeters squared and that it had a height of 7 centimeters. Right? So that actually gives you enough information. If someone's already worked out the area of the weird shape, you can do the rest. So it's going to be A, which is 62, times the height of 7. So that's 434. And remember your units of centimetres squared. Oh, cubed. We're dealing in 3 dimensions now, remember? We're dealing with volume. All right, so 420 plus 14, yeah. I really don't want things going on the internet wrong, but yeah. Now, in the case of a cylinder, they might tell us that the height there is 4 metres, and they might tell us that the radius there is 0.8 metres. No, I'll make it smaller, 0.6 metres. So in a case like this, I could go straight from the formula. Volume is pi r squared h. Remember, in all your working, state the formula, then put values in, then give us a solution. Don't just give me answers. It is not okay at the year 10 level. So here, volume is pi times the radius squared times the height. You will have to put that in your calculator. So pi times 0.6 squared times 4. And it's giving me a volume of 4.52 meters cubed because we are, again, dealing in volume. So, how do you feel about that? Good? All right. There are 2 additional concepts I need to make sure that you remember. I'm happy for you to go journey off onto this on your own, but I'm just going to jog your memory about a couple of things. Length, area, and volume conversions. So you still need to be able to do them. I'm not going to do great examples of them, but revise length, area, and volume conversions. So millimeters, centimeters, meters, kilometers. All right, that's your normal length changes. And we fill this out fairly standard. How many millimeters are in a centimeter? You should be able to tell me 10. How many centimeters are in a meter? You should be able to tell me there's 100 centimeters in a meter. How many meters are in a kilometer? You should be able to tell me 1,000. Now, in turn, if I'm going to a bigger unit, it will be a smaller number. So if I'm going to a bigger unit and it's going to be a smaller number, I'm going to divide in this direction because they're going to be smaller numbers. On the other hand, when I go down to a smaller unit, I'm going to get bigger numbers. So I multiply in the other direction. And you need to be able to do that in practice. You need to be able to move through them. So at the moment, that's showing length. Right? So that at the moment is length. How do I change my conversions so that they're all dealing with area? I know. I'll mysteriously pause it. Can you tell the difference? Everything got squared. So instead of dividing by 10, when I'm dealing with area units, I divide by 10 squared, which is 100. Instead of dividing by 100 to go from centimetres to metres, I divide by 100 squared, which will be 10,000. That's all that changes. All right? Your conversion units have to be squared when you're dealing with squared units. What's going to happen when I'm dealing with volume? Want to have a guess? Shall I mysteriously pause it again? Oh, the world's changed again. Now we're dealing with conversions in volume. So guess what happened now? Length is in 1 dimension, area is in 2 dimensions, it's surface. volume's in 3 dimensions. It relates to capacity. So now I'm cubing all of those units. So instead of going from millimeters to centimeters, dividing by 10, I'm dividing by 10 to the power of 3, which is 1,000. Instead of dividing by 100 to go from centimeters to meters, oh, where's my cubed? Can't turn back time and fix that on the area one, sorry. Now I'm dealing with cube units, right? So to go to centimeters cubed to meters cubed, I'm now dividing by 100 cubed, which is what, 1,000,000? 6 zeros, 1 followed by 6 zeros, it'll be 1,000,000, won't it? So that's how it works. 100 squared, that's big. 1,000 cubed, that ends up being 1,000,000,000. 1 followed by 9 zeros. So that's a huge, huge conversion going between meters cubed and kilometers cubed. All right, if you wrote down the area one, please make sure you put millimeters squared, centimeters squared, meters squared, and kilometers squared there. Accidentally left it out of the last section. Now, the other thing you need to be able to do is deal with capacity. So, in that case, it's different again. You need to be able to deal with capacity, which means moving between milliliters, liters, kiloliters, and megaliters. Megaliters is just 1,000 liters. Don't get fazed by that. So there, and there. How many milliliters is in a litre? Hopefully you'll say 1,000. How many litres is in a kilolitre? Hopefully you'll say 1,000. How many kilolitres is in a megalitre? Hopefully you're getting 1,000 out of that as well. All the conversions with capacity are in 1,000. Next thing we have to do is conversions. I'm making sure I don't forget it. Here, when I go to a bigger unit, it'll be a smaller number. So it's going to be divide all along the top. And in the other way, when I go to a smaller unit, it's going to be a bigger number. So it's all going to be multiply. You need to be able to move between milliliters, litres, kiloliters, and megaliters. That's for you to practice from earlier exercises in mathematics. The other thing you've got to do is be able to conversions between volume and capacity. So here, and remember how we had units of volume? We had millimeters cubed, centimeters cubed, meters cubed, and kilometers cubed. How do you convert between those cube units and these capacity units? There is one particular rule that's critical for that. You may or may not remember it. It's 1 centimetre cubed is equal to 1 mil. There are some other conversions you can use that are useful as well, and I will show them. If I multiply both sides of this by 1,000, you'll get the rather useful relationship that 1,000 centimetres cubed is equal to, what's 1,000 mil? 1,000 mil is 1 litre. Right? So that's useful. And if you multiply both sides by 1,000 again, you get another useful conversion between the two. And that is that 1 million centimetres cubed. 1 million centimetres cubed happens to be 1 metre cubed. Look back over your previous conversion if you're not so sure about that. But 1 million centimetre cubed is 1 metre cubed, and that's the same as 1,000 litres. Or indeed, you could write that as 1 kilolitre. Right. So there, all three of them can be very useful conversions, but they all start at this basic beautiful relationship that 1 centimetre cubed is 1 mil. You should be very happy we are dealing with the metric system, because a lot of people are still dealing with terrible, terrible, horrible conversions between all of these units that we don't really want to be involved with. All right. Students, from there, you can look at the text examples. Text examples are a little bit different. Some are similar, some are different. Give you a bit of a feel for some different ways of looking at it and different approaches, but it's still very similar. This all leads into exercise 6F. All the best. Have fun. Bye.